This is part 2 of going through my brother's grade 11 physics homework. We're dealing with a crash test for a car which collides with a solid barrier. The car initially travels south at 100 kilometers per hour, and then the crash test dummy moves 78.0 centimeters south during the collision. And then the engineers want to know how much time does the collision take and what is the passenger's acceleration during the collision. We'll start by writing down what we know. The initial velocity is 100 kilometers per hour, and the displacement, or delta x, is 78.0 centimeters. And we want to find the time and the acceleration. There's another piece of information hidden in this problem, and you have to read between the lines and visualize the word problem, because the car is crashing and coming to a stop, meaning we also know the final velocity is going to be 0 kilometers per hour. If you don't catch that, you'll get stuck. Now, it's a red flag that there are two different units going on here, kilometers and centimeters. So let's convert everything into meters and seconds. 100 kilometers per hour is the same as 100,000 meters per hour, since each kilometer has 1,000 meters. And then an hour is going to be 60 minutes times 60 seconds, or 3,600. And dividing 100,000 by 3,600 is going to be 27.778 meters per second. 0 kilometers per hour is luckily 0 meters per second. And then 78.0 centimeters is the same as 0.780 meters. So his teacher has given him a list of formulas to use, and it's up to the student to figure out which one. We know VI, VF, and delta x, and we want to find delta t. So the best choice is going to be an equation which uses only those 4 variables, which would be this one. Since we already know delta x, VI, and VF, this equation will only have one unknown, and that's going to be the best way to solve it. Some people like to plug in the numbers before they rearrange and solve it. I think we should rearrange first. You'll remember that I talked about isolating terms first, but this whole thing can be considered as a single term because what's inside the brackets here can't be separated. Delta t is multiplied by 1/2 and the brackets, so we have to divide through by the entire quantity in the brackets, which is VI plus VF, and we also want to divide by 1/2, which is going to be the same as multiplying by 2. Plug and play, it's the easiest part. 0.0562 seconds. To find acceleration now, you have your pick of all the equations, so choose the easiest. Again, this is the term which contains a, so we want this all by itself. So let's move VI over to the other side by subtracting it. So VF minus VI equals a delta t. And then we just divide everything by delta t, creating one big fraction. Negative 494 meters per second square. Making special note that the acceleration is negative, and it makes sense that it's negative because the car is slowing down, which is a negative acceleration.